Sharma from NIT ROURKELA, BTECH first year, and this is my very first video of my channel. So today we are going to discuss about proper choice of coordinate axis. Now, choosing a proper coordinate system is very important for solving a problem, and today I'm going to demonstrate this with the help of a few examples. So let's consider this example. So as per the question goes, find the time and velocity of the projectile when the direction of motion is perpendicular to its initial direction of motion. So how do we do that? So first, let's draw the trajectory first. Okay, and then see. So now for first we are going to take a coordinate axis along the direction of this motion. That is inclined. That is, the axis is inclined at angle theta with the horizontal x-axis. So this is our first axis, and other axis perpendicular to this axis. Okay, this is a new coordinate system on which we are going to work, and let's suppose this is the position of the particle at time t equals to t naught that we are going to determine. And so now we can see, now the concept is, this is our y prime axis, this is, let this be our x prime axis. So now the concept is that at this instant, when the velocity of the projectile is perpendicular to its initial direction of velocity, so that instant the velocity along x prime axis will be 0. So we are going to write that condition and get a result. So let's resolve the gravity in its components along these axes. This is g, this is angle theta of course, and this is g cos theta, and this is g sin theta. Okay, so now I'm going to write the equation along x prime axis. We are going to use v x prime equals to v minus g sin theta t. Okay, and we know that at this instant it is going to be 0, so this is going to be 0. So we have, from here we can have a result, t equals to v by g sin theta. So we have it here. This is the time. So we have determined our time. Now it's time for finding the velocity. So how do we do that? So like suppose for this, assume that the velocity at this instant is v naught. Okay, so with the help of little geometry you can determine that this angle is theta, and this horizontal component is v naught sin theta, and okay, and we know that now you need to switch back to the original coordinate system. Okay, x and y coordinate that was predefined, and we know that the horizontal component along x-axis will not change because there is no acceleration along horizontal axis. So from there we can get a relation. So we have here v cos theta and perpendicular sin theta. So we can have v cos theta equals to v naught sin theta, and from here you have a result between the velocities. V by v naught equals to tan theta. Done. This is also done. Okay, so you can see that with very less calculation we got our results very quickly. So let's solve this. So as we can see, this system comprises of two discs mass of mass m, radius a, and mass 4m and radius 2a, and that is connected by a massless rod L, and this entire system is rotating with an angular velocity omega about this axis, and we are supposed to find the coordinates of the center of mass of this system. So first we take an axis along this line, let this be x prime, and we choose a perpendicular axis to x prime, that is y prime, and let's suppose the center of mass is located somewhere here. We know that it would lie on this line only, that's x prime axis, by symmetry. So this now this distance is x prime cum, fine. And let this angle be theta, and so now we can easily find x prime cum. Now x prime cum by center of mass formula, you can find this m into L plus 4m into 2L by 4m plus m, okay. And so now you have the result, and that is 9L by 5. Now having found this distance, now we'll do the analysis of this system, how this system is moving. So we know that it is moving with an angular speed omega about this axis. If you view from this above the z-axis, you'll see that the center of mass is moving in a circular path in xy plane. See, something like this. It would appear to be something like this. See, this is x-axis, this is y-axis, okay, and the entire system is moving with an velocity, suppose omega prime, okay. The center of mass is located at a distance see this x prime cum cos theta, isn't it? I'm talking about this distance. See, this distance, this is the distance we are talking about. So it's located at a distance x prime cos theta from the center of mass. Not just that, but so we can see from here that x coordinate and y coordinates are not constant, they are time dependent, because at an arbitrary time, see, it would appear to be like this. Say, suppose at time t equals to t naught, the center of mass makes an angle phi with the x-axis. So this x-axis equals to omega prime t, okay. So now we can write the x coordinates and y coordinates as x coordinate will be something like x prime x cum cos theta cos phi, and y cum will be equals to x cos cum cos sin theta, cos theta sin phi. See, we're just taking this projections here. That is where it's we are using the polar coordinate concept. So this is we can do, and yes, we know that phi is equal. We know that phi is equal to omega prime t, and also uh, we need to know. We can also see that tan theta equals to a by l. Okay, and omega prime. What about omega prime? Omega prime is the omega prime can be written as uh, omega prime can be written as omega sine theta, that is equals to omega a by root under L square plus a square. Now how do we know that? See, the omega of the system center of mass about this axis is along this x prime axis. So what we're gonna do is we gonna take the x prime's component along z axis, okay, from this direction to this direction. That is what we are doing. So we get the omega prime. So this is the value of omega prime. Now finally and one more thing is you can see that the com is always constant. Okay, the z com is always constant here. This point remains always constant. This is time independent. So finally we can write the expressions. See, com, that is equals to x as a function of time, y as a function of time, and z. Okay, and so we have x as a function of time. We can write x com cos theta cos phi, which is equals to, we know the x com is equals to 9l by 5. Cos theta is l by root under L square plus a square, and cos phi we can write as omega prime t, and you can use this value in this equation. Now we are going to find the ycom, that is as a function of time we write x prime com cos theta sin phi, and 9l by 5 l by root under L square plus a square sin omega prime t, and for z com we have, this is time independent as said earlier. This is x prime com sin theta, it is equals to 9l by 5 a by root under L square plus a square. So we have finally found the expressions for x com, y com, z.